Hello everyone, I Dr. Udhesh Kumar welcome you all in this course titled Digital Logic and Circuit Simulation. In today's class, how we design a sequential circuit means clock sequential circuit by using a flip-flops. How we design a clocked sequential circuit means designing of clocked sequential circuit. What is here? In clocked sequential circuit, suppose what are the steps we follow for designing a clock sequential circuit? First is find during designing of clock sequential circuit, how many number of flip-flops are required. And when we find a number of flip-flops required, this depends on the number of previous states and next state. Suppose here we have to given the next state value in terms of, suppose here the value of given as, or suppose we find a value of AT plus 1, which depends on the value of what AT, BT and input X. Similarly, we find the next state value of second flip-flop BT plus 1, that is what AT, BT and X. This is nothing but a summation of suppose 0, 1, 3. This is what summation of 1, 2. This means here how many here these previous states are what? 2 previous states in this for generating the next state AT plus 1. Similarly, this means here 2 previous state and 1 input X for generating the value of next flip flop of second. Here 2 next states are given and 2 previous states are there. This means we can say that how many number of flip flops are used to design this clock sequential circuit. There are 2 flip flops are used, and that are any type of flip flop, whether it is a JK flip flop or SR flip flop or T flip flop. This depends on your choice which flip flop you use to design a sequential clock sequential circuit. First find the number of required flip flop in a circuit, and which depends on the number of previous and next state. Second step is what? Determine the state table and find the value of input of each of the flip flop and their output. Simply determine the state table. For when we determine the state table, here the inputs are given as what? AT means the value of previous state, BT the value of next state, and here what is the value of X. Based on these 3, we will determine the value of AT plus 1 and BT plus 1. Here AT plus 1 and BT plus 1 are determined. Then we determine whatever the input of that particular flip flop. Here whatever the input, suppose we want to design a circuit of by using a JK flip flop, then what is the input JA, KA, this depends on previous state AT and AT plus 1. Similarly, we design a for second flip flop, the input are suppose JB and KB, this is JB and KB, and this determines based on the excitation table of JK flip flop, and we also determine what is the final output Y. Because in a combinational circuit there are 2 types of output, one is the next state and another one is the sum output generated. Here output generated is Y, and this depends the value of Y, suppose the value of Y is written in terms of AT, BT and what, that is X. This is written as summation of AT, BT and X. This is written as summation of 1, 3, 5, 7, 1, 3, 5, 7 and so on. So, this means in these particular min terms corresponding to AT, BT and X, the output is 1, rest combination the output is 0. So, this means here determine the state table consisting of what? The previous state input value, then the next state, and based on the, this is for first the input of first flip flop JK, because there are 2 flip flops are required. So, JK, what is the previous state? Previous state is AT and next state is what? AT plus 1. Similarly, for deriving the value of JB, KB, we use the excitation table of JK flip flop, and here we consider the previous state is BT and next state is BT plus 1. And the value of Y here simply given that when in the combination of AT, BT, X, in the combination 1, 3, 5 and 7, the output is 1. And after that what we have to do, after designing the state table of given problem, design a K maps for each of the inputs of flip flop and output Y. So here design a K map for each of the inputs of flip flops like as a J, K, JB, KB and output Y, and then find a simplified expression for these input in terms of what? In terms of AT, BT and X, and then design a sequential circuit by using sequential circuit for the given problem using flip flops, JK flip flops or D flip flop or T flip flop. So here when we design a circuit by using a JK flip flop, here we use a input JK, JB, KB because there are 2 flip flop. When we design a circuit by using a D type flip flop, so here we use a excitation table of D flip flop, and in a D flip flop only single input is there. That is why here use a DA, and for previous determining the output DA, we take a previous state AT and next state AT plus 1. For determining the output DB, we use here BT and BT plus 1. Similarly, we use a T flip flop or we use a SR flip flop to design a sequential circuit. Let us consider it through example design of sequential circuit using JK flip flop. We design, suppose here the expression for next state and outputs are given, means design the sequential circuit using JK flip flop in which the value of next state and output are given as this expression, given by these expression. Here AT plus 1 is what? This depends on the value of AT, BT and X. Here X is what? Input. This is previous state and this is also previous state. This is previous state of flip flop, previous state of flip flop A, this is previous state of flip flop B. Similarly, so this means in what particular combination the output of next state is 1. In the combination means when the value of AT, BT and X are what? When the value of AT, BT and X are written as 2 means that is 0, 1, 0, 4 means 1, 0, 0 and 7 means 1, 1, 1. So when AT, BT and X are these combination, then the output AT plus 1 is high. Similarly, BT plus 1 is high when in the min terms 1, 3, 4, 6, 7, and similarly the output value which is determined which based on the value of previous state AT, BT and X. In the combination 0, 1, 5, 7 the output is high, in a rest combination the output is low. Let us, what are the steps performed? First find the number of required flip flops. Here the number of required flip flops are, there are 2 previous and 2 next state, this means the number of required flip flop are 2, and we use any 2 flip flop like as we use either both JK flip flop to design circuit or both SR flip flop are used to design a circuit, or T flip flop is used or D flip flop is used. Any flip flop is used to design a circuit, and let us suppose here we use a JK flip flop. When we use a JK flip flop for designing a circuit, first we know about the characteristic table and excitation table of JK flip flop. Here there is a need of excitation table, and excitation table is derived from a characteristic table. If you not know the excitation table of JK flip flop, then first derive the excitation table of JK flip flop from a characteristic table of JK flip flop, and then we use this excitation table for determining the input JAK, JAKB and so on. So here the steps are, means first find the number of required, 2 flip flops are required. Second one is the determine the state table, find the value of input of each flip flop. Second, since 2 flip flops are required, that inputs are named as J, K, JB, KB and so on. Previous states are what? AT, BT, previous state of first flip flop is A, AT, and previous state of second flip flop means B flip flop is denoted by simply BT. And here step 3 is design a state table of a given problem. So this is the given problem, we design a state table for that, and after that design a K map for J, K, JB, KB and output Y, and find the simplified means minimized form of Boolean expression for each of the input of the flip flop like as J, K, JB, KB and output Y, and finally we design the sequential circuit for the given problem by using a JK flip flop. Here what happens here? Let us, here AT plus 1 means the previous states are given, previous state values are what? 0, 0, whatever the input 0, 1, when both input 0, 0, these are the combination are written as simply this is the combination 0, 1, 2, 3, 4, 5, 6, 7, because only 8 possible combinations are there, because there are 3 inputs A t, B t and x. That means when that start from the value 0 0 0, similarly 1 0 0 1 0 1 0 and so on. And what is the here the next state is what? The next state is given, the expression for next state is given in the problem. In the combination, when in the minterms 2 4 7, here we can say that in which 2, this is the minterm 2, then 4, then 7, the output of next state is high and rest are 0. Similarly, B t plus 1 is what? 1 3 4 6 7, means in 1 0 0 1, that is high. Similarly, 3, this is high, this is 0 1 1, that is 3 high, then 4, this is high, then 6 and 7, this is 6, that is high, and 7, this is high. Here what is the output? We directly, the output expression is given y A t B t, which depends on these 3 value A t B t and x. In the combination minterms 0 1 5 7, so simply this is written as 0 is high, 1 5 and 7, the output is high. After that what? Here are 2 flip flops, this means the number of inputs are 4. First flip flop input are denoted as J A K A, second flip flop input is J B K B. And this is the excitation table of J K flip flop, means when previous state for J K is denoted as what? Previous state for J K means that is denoted as A t. Previous state for J B K B, that is denoted as B t. Next state for J K is what? A t plus 1, and that is this is B t plus 1 as a next state for second flip flop, and based on the value of previous state A t and next state A t plus 1, we will determine the value of first flip flop input of first flip flop, that are named as J K. This is the excitation table, means when both previous and next state are 0 0, what is J input? 0, K is whatever the value, means that is x, means that is either 0 or 1, 0 1, that is what? 1 x, 1 0 x 1 and 1 1 x 0. So based on this, here we determining the value. Here we can say that previous state, first we find the value of J K. Here A t is what? 0, B t is A t plus 1 is what? 0, then both 0 0, that is written as what? 0 x. Similarly, second one is what? This is 0 and this is again A t plus 1 is 0, then again this is written as 0 x. Similarly, this is 0 and this is 1, this means 0 1, what is the value? 1 x, this is written as what? That is 1 x. Similarly, again this is 0 0, again that is 0 x. Similarly, 1 and 1, in 1 1, that is x 0 is written as here. Similarly, 1 1, again this is what? This is 1, this is 0, 1 0 x 1 is written here. This means x 1 is the value of J is x and the value of K is 1. And similarly, when previous state value is 1, next state value here in this combination, that is 0 1 0, what will be the value? That is x 1, and here this is 1, this is 1. This means what will be the value of J A and K? That is 1 1, that means what? X 0. In this way we will determine the value of J A and K. Similarly, from previous state B t and B t plus 1 next state, that is the previous B t is the previous state of second flip flop and B t plus 1 is the next state of a second flip flop. Based on this value, we will determine the value of J b and K b. Similar process we use here when we determine the value of J b and K b. Here we use what is B t? B t is 0, this is 0 and 0 0, what? That is 0 x. Similarly, 0, this is 0, this is 1, 0 1, that is 1 x, and similarly 1 0 1 0, that is x 1 is written here. Similarly, 1 1, that is x 0, and in this way we will determining all the value of J b and K b. After that, what? This is what? This is nothing but a state table for a given problem. It consists of the previous state input, then next state value, next state outputs are given by a function, and then output y, that is also given as a function, and here we determine the value of J k flip flops, like as a 2 flip flops. J k flip flop used here to represent a function, these outputs and next state. This is J k. If we determine the value of J k, J b, K b based on the previous state, next state, based on the previous state value and their next state value. After that, what we have to design the k maps for J, K, JB, KB. This is what we design a k map for J, KB, k map for J. Simply we find a k map for J. What is the k map for J? This is a 3 variable function, that means AT, BT, and this is what X is the third input, that is X. Here this means this is a 4 cross 2. What are the values here? Values we put J, that is 0 0 1 0, that is 0 0 1 0. This means 0 0 1 0, then X X, all are X X X X here, and this is 0, this is 1, this is 0 0 0 1 1 1 1 0, that are written in a grey code. Then we find a group of ones. Here this, when we find a group of ones, these two are adjacent squares only, then we take this X, this X value is treated as 1, and here we write what is the JA. JA is written in terms of AT BT. This is what here BT is fixed, BT is 1, and here X is 0. This means that is BT into X complement. Similarly, we design a k map for JB, k map for KA. What is the k map for K? This is again AT, BT, and this is X. This is a 4 cross. This is what 0 0 0 1 1 1 1 0, that is 0 1. Then what happens here? We put the value, that is what 0 1, this represents a minterm 0 1 2 3, then 4, then 5, then 6 and 7. So here we can simply find the value of X X. First 4 value of X X X. First we find the value of X, this is also X, and then what X X, then 0 1, this means that is 0, that is 1, and then 0 1, then 1 0. How we simply, when we combine these two groups, there are two groups are there, one group is this and another group is what, this X and this is combined. This means this represents what, this represents, here B is fixed, this means BT X complement, BT X complement, and similarly what is this here, this group represents here, this is 1, but what 0 0 1 0 means the BT is fixed, BT complement into X, and final expression for Ka is written as what, that is BT X complement BT plus X into BT complement. This is the expression for K. Similarly, we design a expression, we make a K map for JB, KB and Y and find the function. Here this is the K map for JB, K map for JB, and after designing K map we write a function. JB is written as AT into X complement plus AT complement into X. Similarly, we design a K map for KB and find a function for KB in terms of AT, BT and X. This is written as what, AT complement X, that is the minimized function, and we find a K map for Y. Here we can see that this is 1 1 0 0, and similarly that is 0 1 and 0 1. What is here? There are two groups are there, this means this group represents AT complement BT complement, and this group represents what, AT into X, that means that is written as here. After finding the Boolean expression for J input, K input, JB input, KB input and output Y, then we simply implement it by using a 2 JK flip flop. So here we taken, this means here we will write a function for J, KB, K, JB, KB, and in this way here we use a 2 flip flops. First flip flop is named as a, this is a flip flop, this is a B flip flop, this is a JK flip flop that is represented by A, JK flip flop that is represented by B. Here the inputs are what? There is a clock pulse which goes common clock pulse goes to all, that is CP, and here this represents nothing but a AT, this is what, AT complement, this is the first output BT, and this is what BT complement, and then here this represents JB, KB, and similarly these two inputs are there, that is named as JA, K. What happens here for expression J, that is nothing but a BT into X complement, simply BT is taken from here and this is input X, and here that is input X complement. Here this is first input is what X complement is taken from here and the BT is taken from here, and both are combined by using a AND gate, and this is supplied to a J input of this. Similarly, for designing K, what is K? X complement B2, X complement B, X complement BT, X complement BT. Here this is what X complement is taken from here, or simply that is this also represents what X complement BT. Simply we take a X complement BT here, X complement BT is taken from here, and then what is the another input, that is X into BT. Another input is what X into BT complement. BT complement is taken from here, X is taken from here, BT complement is taken from here, and this is, these two are combined by using X OR gate, and this is supplied to input K. Similarly, what is KB? JB is what nothing but a X complement AT. Here X complement is taken from here, X complement is taken from here, X complement is taken from here, AT is taken from here, AT is this, this is AT, AT is taken from here, and then simply combine both by a one AND gate. Another is component of JB is what X into AT complement. Here AT complement is taken from here, AT complement is taken from here, AT complement is taken from here, and X is taken from here, AT complement is taken from here, X is taken from here, and then combine both by using AND gate, and this is what, then take a OR, apply OR option, this is what, that is JB. Then this way simply JB is provided, and next is what KB, KB is what X into AT complement. Here X into AT complement, this is what nothing but a X, this is what X into, this is X, what this is X into AT complement here. This means here the first input is what X complement BT is what here, another is taken from one input is another is taken from here, third is what JB, for JB X complement AT, X complement AT is taken from here, another component of this is X into AT complement is taken from here, and X is taken from here. This means this represents a, this represents what, this represents X complement into AT, this represents X into AT complement, and here that is what X into KB is what X into AT complement, means same is X into AT complement, that is also provided here as a KB. Then finally what will be the output for Y? Y is nothing but a AT into X plus AT complement BT complement. So here simply AT complement is taken from here, BT complement is taken from here, this is one component, and this is combined by using a AND gate. Another is what AT into X, AT is taken from here, AT is taken from here, and X is taken from here, X is taken from here, then simply this is, then both are combined together by using a OR gate, and this represents the output Y. So this is the simply sequential circuit diagram using a means clock, because both flip flop have a same clock pulse. This is a sequential clock sequential diagram of a given problem. Now suppose in some cases all the states are not given, means some of the states are unused, then how we design a clock sequential circuit with unused state? Like as a some of the circuit with m flip flops would have 2 to the power m states, means suppose we use a there are m number of flip flops, then from m number of flip flops how many states are represented, states of the flip flop, that is maximum of 2 to the power m states are there. In some application all the states are not used, only some states are used, means in some application less than 2 to the power m states are used. This means at that situation we not simply we not take a unused state during design of a state table. Here states that are not used in the target sequential circuit are not listed in the state table. We only list states that are used, not we list in a state table the states which are not used to represent a circuit. When simplifying an input function to a flip flop, the unused state can be treated as don't care condition. Simply the states which are not used, that are treated as a don't care condition. Suppose, let us suppose the circuit, we design a circuit in which only the states 0 0 0 means when we use a 3 flip flops, then only the states 0 0 0, 0 1 1, 1 0 1 and 1 1 are used, and rest of the states are not used. So, when we simply take it, then what are the states which are not used, means these are used whatever the input combinations and output combinations, these are represents the states value, like as what here AT, BT and CT. These 3 flip flops are used and 1 input are used. So, here in which combination which of the states are not used, 0 0 1 are not used, 0 1 0 means state 2 is unused state, and similarly 1 0 1 means here 1 0 0 4 state is, here we use only 0 3 5 and 7, this means 4 is also not used, 1 0 0, and when the states value are 1 1 0 it is also not used. Whatever the value of x, here the value of x is equal to 0 or 1, when x is 0 this means this is 0 1 0 0 1 0, that represents a m2 min terms m2, when this is 1 1 this represents a min term m3. Similarly, when this is 0 1 0, then again there are 0 and 1, 0 1 0 0 that represents m4, and similarly that represents a m5. Similarly, here 1 0 0, when this is 0 this represents a m8, when this is 1 that represents a m9, and similarly here the states input are x is 0 or 1, when this is 0 that represents a m12, and when this is 1 that represents a m13, means these are a unused state. When we design a circuit that uses only these states as input and rest of the states are not used in the circuit, then simply first we recognize what are the states that are not used in a circuit, and then simply we treat these unused state as a don't care for deriving the inputs of a flip flop. Let us take design a sequential circuit of a given state diagram using a T flip flop. Why we use a T flip flop here? Because it is easy, excitation table is very easy. When both previous state and next states are same, the output means input T is 0, and when both states are different, then the input T is what, that is 1. So, here let us take a 3 previous state, where here the suppose the states are used only what states, that is states 0, suppose there are 0 and this is only 0, then 3, then 5, 0, then 3, then 5 and then 7. Only these states are used. This is the state diagram. What happens in state 0 means that is 0 0 0, state 3 means 0 1 1, and state 5 means 1 0 1, and state 7 means all the values are 1 1. What will be the next state when x is equal to 0? When x is equal to 0, the next state is what? Here we simply see that this is a previous state that represents what? 0. This is the also this is the previous state that represents a 0. In this is simply 3, this is 3 states, and this is 5, then this is 5, then this is 7, this is 7, means only the states used are 0 0 0 only the states 0, 3, 5 and 7 are used. What will be the next state here? What is the next state here? X is equal to 0, we can say that this is a 0. This is what we take a decimal value here, decimal value simply 0, that is what 0, 1, 1 means 3. This is 1, 0, 1 means 5. This is 0, 1, 1 means that is 3. This is 1, 1, 1 means 7. This is 0, 0, 0 means 0. Again this is 0, 0, 1, that means 3, and this is what, that is 1, 7. This means what happens here, when we simply apply the input value, suppose input output are represented in like x, y, here x represents the input and y represents the output. When we apply input x is equal to 0, we will move to the same state, means, and what will be the output here? The output is what, 1. Here it is simply when we apply a 0, output is 1 and we will in the same state. What happens when we apply a 1 here? Simply we will move to state 3, 1 as input, and what will be the output? Output is also 1. What happens when we are in the state 3? State 3, when we apply a input 0, we will move to state 5. When we will apply a 0, we will move to state 5, and what will be the output? Output is 0. Similarly, what happens when we apply 1 in state 3? State 3, when we apply 1, we are in the same state 3, and what will be the output? That is also 0. Similarly, we move from state 5, when we are in the state 5, we will move to 7, when we apply a input 0, this is we will move to 7, means when we apply input 0, and what will be the output? Output is what, that is also 0. What happens when we apply 5, input 1, here we will move to what? Here we will move to 0. 5, when we apply a input 1, we will move to state 0, and what will be the output? 5, when we apply a 1, what will be the output? The output is also 1, that is written here. What happens when in a state 7, we are state 7 and we apply a input 0, x is equal to 0, we will move to state 3. This means 0. What will be the output in that condition? Output is what? That is also 0. And when we apply 1 here, 1 as a input, then we will move in the same state 1, and output is what? Output is also 1 in that situation. So, this is the state diagram. Suppose this state diagram is given, not this table, this state diagram is given. Here state diagram is given, then simply we design a table from this state diagram. And if the state table is given, then we design a state diagram, and here some of the states which are like as a, the state 1, 2, 4 and 6 are not used here, means when we take a input value x and x is equal to 0 and 1 with that states, this means we will find these terms m2, m3, m4, m5, 8, 9 and 12, 13, in which there is a don't care condition, and rest are given here. After finding this, after making this, means there is a previous state, then input, previous state is what? 0, 0, 0, input is 0, then we will move to the same state, next state is same 0, 0, 0, and output is what? That is 1. Similarly, from this table, this state diagram, we determine the what happens when we are in state 0, 0, 0 and input is 1, output is what? 1, and then we will move to state 3, this is 3. Similarly, we convert this state diagram in the form of a state table, and after that simply here the objective is to design a clock sequences circuit diagram by using a TA flip flop. We use the excitation table of flip flop, T flip flop, and then be determining the value of input value of TA, TB and TC. And here what is the, this means the value of TA is based on the value of AT and BT, that is why both are in same color. What happens here? 0, 0 means the result is, we can know that in case of excitation table of T, the input T is 1 only when the previous state, one previous state is have a value 0 and another has a 1, and similarly 0 when both previous and next state have the same value like as either 0 0 or 1 1. Here simply we see that 0 0, that means what is the TA, that is 0 0 0, again TA is 0 0 1, the 1, this is 0 0, again 0, this is 1, and what is 1 here, that means 0, again 1 0, that is 1 1 0, that is 1, and this is 1 1, that means 0. In same way we will determining the value for TB based on the this BT and BT plus 1, and similarly we determining the value for TC based on CT and CT plus 1. That is why here AT plus 1 and TA are in same color, because TA value is based on AT and AT plus 1. Similarly, the value of TB is based on BT and BT plus 1. That is why BT plus 1 and TB is same color, and the value of TC is based on CT plus 1, and that is why all CT plus 1 and TC are in same color. We will determining the value, and after that what we simply design a K map for CT plus 1, we design a K map for all the inputs of JK flip flop, and then simply find the output. This is not a JK flip flop inputs here, wrongly written, that is a T flip flops input, T flip flops input. This is a by mistake it is written here, and similarly here that is also a T flip flops input, T flip flops input, state table of given state, this is a state table, and then simply find a K map for TA. K map for TA is what? We design a 4 variable K map for all of the TA, TB and TC and Y. It is simply represented like here. This is inputs are what? AT, BT, CT and X. This is a 4 variable K map. And simply we put the value of TA. TA is what? First we put the value of don't care condition. First we put the value of don't care condition, in which 2, 3, 4, 5, 8, 9 and 12, 13 the values are don't care. Simply here this is written as 0 0, 0 1, 1 1, 1 0, 0 0, 0 1, 1 1, 1 0. In the combination 2, 3, 4, 5, 2 is represented like 0 0, 1 0, this is don't care, 3 is don't care, 2 3, then 4 5, that is means 0 1 0, this is 4 5, and then 8 9, 8 9 means 1 0 0 0, this is 8, this represents a 9, and 12 11, sorry 12 13, 12 is represented like this and 13 is this. In these particular min terms the output is what? Don't care, and rest here AT plus 1 it's here TA is given like as a in a combination 0 0 0, that is 0, in a combination 0 0 0, that is 0 0 0 1, that is what? This is 0. So 0 0, that this is 0, this is 0. Similarly in a combination 0 1 1 0, 0 1 1 0, this means that is 0 1 1 0, what will be the value? 0 1 1 0, the value of TA is 1, this is 1, and other combination this is 1 means that represents a what? 1 0 1 1, that is 1 0 1 1, this is 1, and then again in what combination this is 1? This is 1 is combination 1 1 1 0, that is means 1 1 1 0, this is 1, and rest are 0 0 0. Here we form a group of ones here. So when we form a group of ones, so we can only make a group of 2 ones, 4 ones here, these 2 ones are combined here, these 2 X are combined here, this makes a group of 4, and another one single one is remaining here. When we make this is grouped together, then either these 2 are grouped or this and this are grouped here. So we simply make this as a group of 2 ones here. This means simply we will find here the values are, this group represents what value? This group represents a value, this group represents a value like as a, this is what? In this group simply we will find the value, this is 0 1 1 1, this means here the value of BT is fixed, that is 1 BT, and another is what here in case of 0 0 1 0, which one is fixed? The value of X is fixed, that is complement, this means X complement. Similarly what this represents? This value represents This is 1 0 means the value of AT and BT are fixed, AT BT complement, and what is here 0 1 1 1, this means the value of x is fixed here, that is 1. Finally, the expression for TA, this means TA is written as BT into x complement plus AT BT complement x. Similarly, we will find the design a K map for TB and find a Boolean expression for TB, then we design a K map for this is TC, and design a simply find after finding a after designing a K map for TC, we will find a Boolean expression for TC, and we also find a Boolean expression for output Y, and in all cases all the K maps these bin terms like as a 2 3 4 5 8 9 and 12 13 are treated as a do not care, and we then simply form a group of ones including a when some of the x are included in the group, and then we find a simplified function in terms of AT, BT, CT and x, and then we simply use a for implementing this diagram we simply use a 3D flip flops TA, DB and DC. This is what T flip flop TA, this is one input of T flip flop, another this is TB and this is TC, and these two outputs like as a simply this is known as a CT complement, this is what this is BT complement, and this is AT complement, and in this way all clock pulse is common in all of the flip flops, that is CP is common, and then based on this based on the output for TA, based on the function determined for TA, TB, TC, we will simply provide the input TA, TB and TC. Here this is based on what? The value of x and the value of AT, BT and CT. In this way we will design a circuit when some of the states are not used, we design a sequential circuit. After that, after finding the Boolean expression for each of TA, TB, TC and Y, we will simply implement a clocked sequential circuit for that problem. This is all over about this problem. Thank you very much.